Hello, welcome to assignment 5 for the Arduino Starter Kit for Electronics. Today we are working on a mood cue. Now what that means is it's going to be an arrow that points to your mood, or that's the example that they put in the book, like go away, enter at your own risk, or come on in, like on your door or something, where you could put a little kind of angle changing to show what your mood is. Now I've made my own special sketch at the end of this video that you'll see. But today what we got to do is the first thing you need to do is watch the video, the extra video. I would start with that. It's only 7 or 8 minutes and it's well worth it because it really does explain things in nice simple terms. It's kind of like a nice version of the booklet. And then read the booklet for Project 5, the mood cue. Now let's take some time. Before you do anything else, before you watch the video that I told you to watch and all that kind of stuff, let's actually spend some time looking at this for a bit. This is going to take a little bit of time. If you look at the circuit, it's not too crazy in the appearance, but let me tell you, wiring this is actually a lot trickier than the diagram makes it, and I had to do some modifications on my wiring just to make it easier to do. So I'll explain some of that with you. So the first thing you're going to learn about is a servo motor, and they can only rotate 180 degrees. That's a very special thing about them. Think about windshield wipers. That's kind of what this project is like a clone of. A servo motor is programmed to go from this degree on your windshield to this degree and then back and forth, right? It could move 180, but it's programmed to work in a certain amount and turn back and forth. That's an example of a servo motor in the real life. If you look up other videos on YouTube about servo motors or about this project, you'll see people talking about windshield wipers pretty often. So you can read about servo motors, talk about them, and then you've got to understand another thing, is that we need to map the function. We're going to use something called a potentiometer, a pot as we call it, and that's kind of just like the other things we've used. It's kind of like the photoresistor that took a signal of light and converted it to a voltage. It's kind of like the temperature sensor we used that took a temperature and converted it to a voltage. Well, now we're going to actually use a twist knob that's going to allow different amounts of voltage. And now if we have something that's allowing different amounts of voltage in and out of a circuit, where are we going to connect it to? Are we going to connect it to a digital read, or are we going to connect it to an analog one? You should know that by now. That's something you should know. Whenever we're playing with voltages, we always want to wire that to an analog in so it can read between 0 and 1023. So think about this. What this potentiometer here will do later when I set it up is we'll give a number between 0 and 1023 as I turn it. 0, 1023. Okay, that's cool. Right, I can get a 0 to 1023 on my potentiometer, but how many degrees does the servo motor rotate? Well, technically 179 if we're being really nerdy. So you could see from 0 to 179. So if I want the motor to turn 90 degrees, that's right in the middle. In servo degrees, that would be 90 degrees. But in the potentiometer reading, that'd be somewhere around kind of in the middle, 512. So what we have to use is something called, and you've done a little bit of this, mapping, right? You're going to have to map functions to calibrate what comes out of one part to another. So, sorry, I just had a little glitch with my wire here. There we go. So you're going to have to take what the potentiometer gives and remap it to what the servo can read, and you will do that in your code when you start doing some different mapping stuff to compare the angles, right? Right there, angle mapping. You'll see that later on line 14 of your code. So that's important. You're going to have to convert voltage from a potentiometer into something a servo motor can read, and you'll be using the map function. We'll talk about that. I guess we should talk about the wiring right now. Let's talk about that. You can see where kind of the rest of the unit's going. We'll talk about that after, but watching the video, reading the book, wiring the board, submitting the code, verified proof, and then you'll have to submit me showing that you made the mood cue work. And you might have to do that on a video or a Google Meet, or we might have to meet in person for that to show that that's working. We'll figure out. However we do videos, because some of the projects that we're doing from now on aren't just lights on and off. There are things moving and reacting and sounds and things like that. So we're going to have to find a different way of submitting stuff digitally. You might have to send video clips. We might have to conference quickly. I might have to actually see you. We'll figure it out. However we do it once is how we'll do it for the rest of the course. So once we figure out a way to communicate with a little bit of video somehow where we can see each other or face-to-face, that's what we'll try and do for the rest of this course. So you'll show me that, and then you will do the questions just as before. I have some questions for Project 5, right? What's special about a servo? How does a servo know how to do? Why is it useful to change 1023 to 179 in the library? What's a potentiometer? What is this, and what is a library? And that's the other really cool thing, is we're going to use something called a library, and we'll get into that in a bit, but let's see. So, a couple wiring notes, and this is very important, because I'm using the same kit you're using in theory, and there is some tricky stuff. First of all, let's see how the diagram has it, right? Now, these are very important. The most important thing is when you take these capacitors, you have to get this right. The side with the stripe like that, right there, always, it is the shorter wire. It has to connect to ground. So look at here. This wire, this white wire I had, where's it connected? It's connected to ground. So you've got to make sure you put the short wire in ground and the long wire in power. If you don't, you could blow them up. You could start a small fire. This could go very bad. So before you ever connect your board to power, you have been warned and you will be responsible for this. Make sure that the line, the little line, is connected to ground. Now this gets very tricky here because we've kind of hacked it a bit. We kind of modified the circuit. So you got to be really careful before you do anything. I'll explain. So first of all, look at where they put the potentiometer in this diagram. It's right here in this little area. Well, look at how much stuff is here. I've got all these wires. I got capacitors. I would have to take this potentiometer, which is spaced out about 4 strips wide, and I would somehow have to fit it in there. I'd have to bend these with pliers and try and make them work, and it would never, ever work. This potentiometer is not the best, but it's what we've got. So what I had to do is I ran extra wires, and I jumped over to the other side of the board because the board's split. But if I run a wire from here to this side, now it's basically as if it's the same strip. So I ran a wire over, I ran a wire over, and I ran a wire over. Remember the top? I ran a ground wire connected to the strip that's connected to ground over here. This is power. It's coming out of the red power to power side of the capacitor, and then I jumped the power over. And this is our analog read that's going to be reading, our analog in that's going to be reading the potentiometer. That goes to the middle. And how it works is you have your 2 here, your negative, positive, and going to the analog read. So I just jumped them there so that I could fit this into the board don't speak too soon there, Mr. Sitnick, very easily, right? It just kind of sits in the board a lot better than if I was going to bend it and twist it. So that's the first thing. I took this and I just kind of expanded it a little bit over. I just used this side of the board by connecting. I had to put extra jumper wires there because they're not connected naturally. So I had to use 3 extra little wires to connect them, and then I put the potentiometer over here just to make it easier. The next thing, and this is in the video that I warned you about too, I told you to watch before you wire. Now remember, in your diagram, look at this. Black, red, white. But guess what? On most servo motors that we're going to be using, black, white, red. Oh no! You could be in serious trouble if you mess this up too. You could blow that capacitor. Luckily, black stays where it is in the diagram, and black, remember, on this wire is running into the ground strip here, and we have put Ooh, that's really jammed in there. The side there to ground. And the other side to power. So I'm going to kind of pry that back in. Hopefully that works. I kind of pulled that out a little hard. And you'll notice that this leg kind of sits a little funny there, but it's not touching anything else, so it's fine. So what happened here? Let's take a look. We've got ground going to the black cable. In our diagram, ground goes to black, and that's where the line side of the capacitor is. So we're good there. But now red goes to power. But our red is down here, so we have to actually flip these two. So I put the red connecting to power here, which means my capacitor, the power thing, needs to be moved one over as well. So I put the power of the capacitor one over. So I've modified this section of the diagram. And then, of course, the one coming out of digital out or digital right, number 9 here, going originally to the white. Well, the white's in the middle of this, so I just went from 9 to where the white is here. So I've basically flipped the power and the pin, and I flipped them, and I've had to kind of change where I put the capacitor. Luckily, the negative is still in the right spot. Now, I'm going to tell you, if you are worried, send me a picture, talk to me before you power this up, because you do not want to blow this one. But if you've got the negative side to negative and the power side to power, which is stretched one over from the diagram, be very careful on this. You should be good to go. The last thing that I will tell you about that's important here is in the code, right? Lots of this is normally we've declared parts, a servo, but we've included a library. What is a library? I think we've talked about this before, but remember, a library is a set of code that you don't need to write a whole bunch of code for this servo motor, because this servo motor, it's a pretty complicated little thing, and it takes a whole separate kind of language to talk to that servo motor how to behave correctly. So we could write all the instructions for the servo motor, but it's a part that is used in so many kits and in so many applications in the world that there is libraries of code that you can just take and plunk into your code, and it puts all of the code for that part in. So here we've included the servo.h, and .h means a library, right? So we've included the servo library that's online. It's built into our program. We just plunk that in so we don't have to write the code. It's pretty cool. That's another thing you're going to need to know. And you could talk, and you've got the setup and the loop. And here, of course, the map function is another major thing that will be asked on tests, and you'll have to be understanding. Anytime you're taking an analog thing and converting it into something that a digital pin could read, whether it's pulse width modulation from a project before, you're going to have to do some kind of mapping, making a corresponding number between, you know, what the analog was originally giving, which is between 0 and 1023, and what the digital pin can take, how it can send signals in different ways that we can program it to. So we'll always have to remap from analog to digital, right? Analog can read a wide range. Digital does 5 volts on or off, high or low. That's it. So we've got to map that function. That's the main things about this. I'm going to give you a demo of it right away. The biggest thing I would say, though, is be careful with the wiring. This is a tricky one. Take your time. Look at all the hacks. I'm just going to leave this here for you to look at, right? I've modified this. I've flipped these, and I had to extend the power wire one over from the original diagram, and I changed where pin 9 was connecting to because of how this was wired differently than in the book. And I jumped everything over for the potentiometer. If you really wanted to be a nerd about it, you could take a bread clip or a jumper clip here, right? And you could actually go and connect separately to each one of these with a wire and then plug it in the right spot depending on where you were. And you would actually have a much more easy to read output from your motor. Another thing, or from your potentiometer. And you'll notice when I show you this, I'm not a total failure at this project, but you'll notice my servo motor will be jumping around, right? So what I want to show you let's see. I'm going to do a little demo here. I've included a wire just to make the pointer on this a little bit easier to see. You don't need to do that, but it's kind of fun. I just kind of bent it around there. It kind of just to make it a little more real. And I also put a piece of sticky tack on the bottom. You could find some way probably to secure it. If you need sticky tack, maybe I'll remember it one day and I can bring it if you're around. So let's take a look at this. I have made my own thing instead of knock, don't knock, right? I made just like how cool I am, basically, right? We've got, I'll turn it all the way to 0 to begin with. And I'll show you the kind of error that comes with this project pretty often. Okay, so let's see. I'm going to plug this in. I'll turn it to 0. I'll fix that wire so it points properly. Right, and see, there's the first thing. This potentiometer is not sitting kind of correctly. It's not sitting clean and flush. So unless you push really hard, if you push really hard, it'll go to the right spot where it's dialed in on here. But as soon as you let it go and it gets a looser connection, the motor starts giving, the potentiometer starts giving mixed voltage, and the servo doesn't know where to move. And look at this. You can even see if you go to the monitor, you'll see it's going to be reading the angle position and it's jumping around too much. But if you push it very firmly, it'll clean up and it'll go to basically 0. So I'm pushing down and it works. Now, if you wired it with bread clips like this, if you got extra time, maybe I can find you some bread clips or maybe you can get some own. Or you could solder a potentiometer with nice, clean, long wires, making sure they don't touch. Then you would be able to like really precisely put the potentiometer in and clip it on, and you could hold the pot and turn it and it would be much more stable. Because look, it's going kind of crazy here until I push it down. And then the reading is back to great. And now if I turn it all the way up, right, and I push it down, I can, as long as I'm pushing down, it's very smooth. But as soon as I lose the stability with that connection, it starts going kind of nuts and it doesn't know what to do. So I'll turn it back to 0 and you can see. And this is what I'd like a video of you showing how it works. So, right, you can make your own things here and take some pictures or maybe video. Like I said, we have to figure that out as we go along. So at 0, Sitnik stinks. As long as I push down, he's okay. Sitnik is great. Sitnik rocks. Technically the truth. Sitnik is the goat. The goats? No, that's just sheep. And godlike status reach. Well, thank you. Who wrote this? So, and I'll turn it back down to Sitnik stinks because, yeah, well, you know, we have our good days and bad days. I'm going to just unplug this because it's a little distracting, but that's the basics of how this this project works. Oh, I should have left it on godlike status reached. Oh, well. But that's the basics. So like I said, let's talk about what you need to do today. This is a cool project. Take your time. No rush as usual. Watch the extra vid and read the book. Wire the board. Submit a picture of the old school way of your board being wired. Write the code and get it verified and submit a picture of that. Upload and show me somehow. Like I said, we'll figure that out. Maybe with a video, but make sure you make a diagram or a paper of your own. I don't just want the servo by itself. I want you to make something creative like that on a piece of paper. Maybe make me laugh. You can make it about anything. It doesn't have to be about me. It doesn't have to be about your mood. It could be anything, a dial kind of rating something. And then you have to do the questions for Project 5 in the sheet that I gave you. So that's the basics of it. I hope you enjoyed this one. It's a cool project. And we'll see you soon. Next, we're going to be making sounds with our Arduino in the next couple projects. So that's kind of cool. We're going to use this something called a piezo. Piezo. I'm just kidding. Piezo. All right. Have a good day. Cheers.